The next major area we shall look at is Western Europe and the North Atlantic in December. In other words, in winter. Firstly, we shall examine the major pressure systems in the region and their effects. Notice the subtropical high pressure, the Azores High, is small and rarely affects Europe in the winter months, but is still a dominant feature in the North Atlantic. However, the major dominating systems are the polar front depressions, with their associated warm and cold fronts. They travel from west to east across the Atlantic, bringing strong winds with persistent rain and cloud. Between these depressions, we find the ridges of a high pressure or cold temporary anticyclones. These give a brief period of generally light winds and clear weather, until the arrival of the next polar front depression. In the Atlantic, there is an influence on the weather from the North American high pressure, which brings polar continental air to the western Atlantic, aggravating the formation of the polar front depressions. Occasionally during the winter months, very cold polar continental air from the Siberian high can move into Europe, giving extremely cold, clear weather. There are several important local winds in southern Europe. The first of these is the Mistral. On occasion, a high pressure can build up within Central Europe, and combined with a low pressure called the Genoa low just south of the Alps, a strong pressure gradient will develop towards the Mediterranean. This causes air to blow quite rapidly through the Rhone Valley, shown here. The other important wind is called the Bora. It flows down the western slopes of the Balkans into the Adriatic Sea. With a persistent cold anticyclone over Eastern Europe and Siberia, a cold pool of air builds up over the Balkans. Eventually it spills over the mountains, and the heavy, dense air rushes down the mountain passes and can reach speeds of up to 100 knots and last for several days. This flow downhill towards the Adriatic is aided by the katabatic effect at night and the funnel effect of the local topography, causing very dangerous gusty winds that can be very hazardous to aircraft operations. Let's now look at Europe and the North Atlantic in the summer months. Notice that the dominating system is the Azores High, which has moved northwards from its winter position and intensified dramatically. This pressure system is a warm anticyclone and gives rise to very clear sunny skies, and temperatures across Europe can rise to 30 degrees Celsius or more, even reaching 40 degrees Celsius in the Mediterranean. The Azores High is a major source of warm tropical maritime air into the North Atlantic region. Polar front depressions can still sweep through the northern parts of Europe and the North Atlantic, bringing rain and strong winds, but now they are noticeably weaker and found at the higher latitudes. The very cold polar continental air affecting Europe from Siberia and Asia in winter now develops a more tropical characteristic. During the summer, a persistent northerly wind can be found to the east of the Mediterranean. This is called the Estesian. A trough of low pressure builds up over Anatolian Plateau in Turkey, and combined with generally higher pressure over the Mediterranean, a strong pressure gradient builds over the Aegean Sea. The resulting winds can intensify to gale force, particularly with local funneling and sea breeze effects. Now we look at one of the most significant regions, Southern Asia. This area stretches from the Gulf of Oman through to the South China Sea, encompassing countries like Pakistan, India, Malaysia and Korea. This area is notable because of the very direct seasonal changes in the weather. Firstly, let's examine the area in December, that is, winter. Note that the ITCZ is well into the southern hemisphere, as expected. This creates active convective weather in the South Indian Ocean from Africa through to Australia, and can create the occasional tropical cyclone. However, over Asia, the dominating pressure system is the Siberian High, whose surface outflow moves towards the low pressure zone of the ITCZ. However, as the air moves south, it gets deflected to the right, and we see the northeast trades, more correctly called the Northeast Monsoon. This wind is relatively cool and dry, and gives little weather across the region. However, when it passes over the sea, it collects moisture, and it starts to warm on its journey towards the ITCZ. When this happens, active weather starts to develop. By the time the air has reached the equator, it is very warm and moist. As it crosses the equator, it will be deflected left and becomes the northwest monsoon. The weather created is much more significant than that of the northeast monsoon. This time we will examine the region during the summer, in the month of June. Notice that the ITCZ has now moved well into the northern hemisphere, and its greatest northerly extent is over Korea, at about 40 degrees north. The Asian landmass has warmed significantly, and a large-scale low pressure dominates the region. The low pressure system of the ITCZ and the Asian or monsoon low will draw air from the Indian Ocean onto the Asian landmass. Notice that as the air moves north over the equator, it is deflected to the right and creates the southwest monsoon, which is like that in West Africa. The southwest monsoon warms from below as it travels north towards the ITCZ, but it also picks up tremendous amounts of moisture from the Indian Ocean. This moisture-laden air becomes very unstable, and very severe convective weather with heavy rainfall develops over southern Asia and persists for several months. This causes massive flooding as the Ganges and Brahmaputra overfill from the runoff. Many hundreds of thousands of lives have been lost in southern Asia from the southwest monsoon and its associated weather. Since the northern Indian Ocean is warming significantly in summer, tropical revolving storms can develop. These can plague areas from the Gulf of Oman to the west coast of Malaysia. In this region, they are known as cyclones. The tropical revolving storms in the Pacific, the other side of Malaysia, are known as typhoons. Typhoons are some of the most violent and active of all the tropical revolving storms, with as many as 20 to 30 storms a year. As you can see, this area of the world has a significant change in the weather from season to season. The dry and cool northeast monsoon in winter gives little weather, but the southwest monsoon in summer provides very significant risks to aviation, and this monsoon needs to be watched carefully, as do any tropical revolving storms.